In today's world, there has never been the best time where precision and transparency is more critical than ever. Regular Tech Talk webinars fall short in thoroughly dissecting and analyzing the technical underpinnings of a solution's architecture. Webinar Q&A sessions often provide elaborate responses, but they are more suited for marketing than genuinely addressing the questions posed by software engineers, the attendees, which to me can sometimes be intellectually dishonest. For example, in the recent outage that paralyzed our technical and digital infrastructure just recently, during the webinar, a question was asked, how does their endpoint work? But there was never mention that their core logic was within the operating system kernel. At Parasoft, we prioritize proof of concept demonstrations that engage matters to the metal. If our solution doesn't work for you, we will collaborate to resolve the issue rather than pushing incompatible solutions. In this session, we are going to examine a small piece of code but whose effect, if unnoticed, is not small. This piece of code has an out-of-bound access into an array. The array in question here is this one. It has 5 elements. We are going to access the 6th element of this array. The valid index that can go into this array are only 0 to 4. Therefore, accessing 5 will be out of bounds as it is accessing outside the valid region. I installed Parasoft plugin in the Visual Studio IDE here. You can see the Parasoft menu here. The Parasoft tooling for C and C++ also works in different IDEs and different operating systems. In compatible Eclipse-based IDEs such as the Texas Instruments Code Composer Studio, NXP ARM32 Design Studio, STM32Cube IDE. If you do not want to use the mouse, the Parasoft command line can also work in a bash shell for CI/CD deployments. Now let us proceed to the discussion of this topic. The dangers of accessing an out-of-bound array. I will subject this code to static analysis using Parasoft tool, best using built-in static analysis, flow analysis standard. Parasoft has 5,000 static analysis rules that covers the best practice as defined by organizations such as MISRA, ISO 26262, DO 178C, CERT C, OWASP, and so on. For this session, we'll be using flow analysis standard, which is the best in catching array out-of-bound access. It is not just one rule, but a set of rules, and surely one of it should capture the impending array out-of-bound access. I'm running the static analysis now. The progress bar is at 50% while it is analyzing. Analysis has completed, and surprisingly, there is no reported access out of bound detected in this piece of code. Remember that this is C and C++, where nothing is what it seems. The question here is, was there really an out-of-bound access? Did the code really write in a region not within the memory region in the G variable? To answer this question, let us debug the code and see things at a lower level. The size of the variable G is 12. The memory region of G, we will view that from the memory viewer of Visual Studio. So 12 bytes here, 1, 2, 3, 11, 12. So I highlighted here in green the region that is only valid for read-write. To make things more readable as we debug, I instead do a memset into this memory region using this FE hexadecimal special value. So we can see now below that the regions where we can do valid read-write access has been marked as FE. And then we are now going to write into the sixth element of an array containing only 5 elements. And here has a value of 5, meaning it will write into the sixth element of the array. We will see below here where that write actually is taking effect. We can see that indeed the byte has been written within the valid region of the memory. This explains why the Parasoft static analysis did not report an out-of-bound access. The Parasoft static analyzer works in tandem with the existing compiler where it is used, as the write of the byte did not occur in an out-of-bound area. Therefore, no violation is reported. Now this goes back, I will stop the debugging now, this goes back to the definition of C and C++, wherein some part of the language is unknown, some part is undefined, some part is implementation defined. It is a dangerous language, but it is the most popular language used in safety-critical applications today. The more the reason why we need to have a robust static analysis. These dangers are well understood by past experiences. If we use another language such as Rust, we will be entering into a new and uncharted territory. The C and C++ is a well-known territory, provided that a robust static analyzer, in conjunction with the best practices as detected and defined by MISRA, CERT C, and different organizations like AutoSAR, already captured these dangerous parts of C and C++. So you can say that the weaknesses of C and C++ is reasonably mitigated by the presence of static analyzers. It is a well-understood but dangerous field. Using C and C++ without the aid of static analysis is dangerous. Now, the reason for this anomaly that we're seeing here is about structure padding. The size of the structure AA here as it occurs right now, is not actually the summation of the individual sizes of its fields, but instead it is the summation of the individual sizes of its fields plus a small amount of padding inserted. If you want to make the size of the array exactly as the summation of the sizes of their fields, then you have to use a language extension, a C and C++ language extension expressed directly via a pragma directive. So if you want to avoid padding, and which is always the case when you're coding for a protocol implementation where exact precision of the bytes is encoded as it travels across the wire, then you have to avoid structure padding. So I'll do that now by writing pragma to insert a language extension. Pragma pack is for packing structure. If you're using GCC, you can also express this intent to extend the C and C++ language to avoid padding using the attribute push 1 byte resolution. Pragma pack then pop. Now that we wrap the structure with this directive, the size of the structure is now the accumulated size of the member fields without any padding involved. Let us debug again the code. Whereas before it was 12, now it is 9 because there is no padding. Yes, view again the memory region. So 12 bytes from here, then more easily we just memset that to FE so that we can see it clearly. And then we are now at the statement where we are about to write the value 69 into this region. We will see where these 69 bytes falls into the memory when it gets written. I'll press the next step now. And indeed, the byte gets written outside the allowed region. This is now an access violation. I'll stop the debugging. Again, this is C and C++ where nothing is what it seems. This is just the nature of the beast. Coding in C and C++ without the aid of a robust static analyzer is asking for trouble. Alright? Well, if you can code in Rust, it's also asking for even more trouble. That is an uncharted territory. Again, C and C++ is dangerous, but it is well understood. With the amount of PhD literature written with the language, it is well understood provided that it is assisted with a robust static analyzer. After this correction, using the pragma extension, let us run again static analyzer using Parasoft to ask if indeed there's an out-of-bound access in this piece of code now. Parasoft does not report an out-of-bound access when nothing is really out of bound. But if there's an out-of-bound as what the compiler is saying, then Parasoft will report it. And it reported here one violation saying that possibly accessing the G elements out of bounds. You can also right-click to view additional documentation of this rule, BD PB array, and the description. There's also an example construction of similar problems and the repair, as well as references of this particular topic and related literatures. So in summary, coding in C and C++ is a dangerous undertaking without the aid of a robust static analyzer. There are open source analyzers, static analyzers out there. I am one of the users of open source tools. But let me tell you, nothing comes close if you use a commercial one. The open source free static analysis, they are helpful. They are very limited. So this is all for my discussion of the dangers of array out of bound access. The code here is small, but the effect of this kind of bug is not small. Thanks for your attendance. Thank you.